Welcome to Physics with Joe. In today's brief video, I'm going to introduce the concepts of position, velocity, and acceleration. I'm going to limit my discussion to one-dimensional motion, so motion along a straight line that's either horizontal or vertical. In a future video, we'll talk about projectile motion or motion in two dimensions, but for today, the motion will only be along a straight line, either horizontal or vertical. What I'm going to talk about is how are each of these three quantities defined? What does it mean to have a value that's positive, negative, or zero for each of these three quantities? And last but not least, we'll look at some different scenarios and see if we can figure out what kind of motion we expect if, for example, the initial position is negative of an object, it has an initial velocity that's positive, and the acceleration points in the positive direction. So without further ado, let's jump right into it. Before I go into the definitions of position, velocity, and acceleration, I want to just quickly start with 2 points. 1. Position, velocity, and acceleration are all vector quantities, which means they require both a magnitude, which is a number plus units, as well as a direction. And you can't completely specify a vector quantity without indicating its direction. 2. In one-dimensional motion, direction is indicated with a plus or minus sign. Positive indicates in the positive direction, minus sign indicates in the negative direction. By convention, unless you're told otherwise, when we're talking about horizontal motion, to the right is considered positive, to the left is considered negative. And when we're talking about vertical motion, up is considered positive, down is considered negative. With that in mind, let's look at the definitions of position, velocity, and acceleration. Position is a vector quantity that describes where an object is with respect to a reference point that we generally call the origin. Position is measured in meters, and we use either x or y to indicate position. X if we're talking about horizontal motion, y if we're talking about vertical motion. So if I said something had a position of x equals negative 4 meters, the 4 meters, the magnitude, that's the distance from the origin, and the plus or minus is indicating a direction. Negative 4 meters would mean 4 meters to the left of the origin. On the other hand, if I said I had a position of y equals plus 2 meters, 2 meters is the distance away from the origin, the plus is indicating the positive direction in the y-axis, which means I am 2 meters above the origin. In everyday language, people often use velocity and speed interchangeably. But in physics, they mean different things. Speed is a scalar and just indicates how fast something's going, whereas velocity is a vector quantity that indicates both speed and direction. If you're going to indicate an object's velocity, you have to give the direction it's moving. Velocity is measured in meters per second, and we generally use v for velocity, with a little subscript x or y, depending upon whether the motion is in the x direction or in the y direction. So vx would be the velocity in the x direction, vy would be velocity in the y direction. And again, by convention, to the right is positive in the x-axis, up is positive in the y-axis. So having a positive value for vx means you are moving to the right. Having a negative value for vx means you're moving to the left. Having a positive value for vy means you're moving straight up. Having a negative value for vy means you're moving straight down. And velocity of 0 means you're not moving at all. Acceleration is a vector quantity that describes the rate at which your velocity is changing. To have a large acceleration means your velocity is changing very rapidly. To have a small acceleration means your velocity is changing on a longer time scale. And if the acceleration is 0, that means your velocity is not changing at all. Now in everyday English language, we tend to use accelerate to mean speed up. But in physics, anytime your velocity changes, you accelerate. And that can happen if you're speeding up, slowing down, or changing direction, which I'll talk about in another video. But for today, we're looking at acceleration in one dimension. Acceleration is measured in meters per second or meters per second squared, and we use the symbol A for acceleration, and then the subscript X or Y to indicate either horizontal or vertical motion. So AX would be acceleration in the horizontal direction, AY would be acceleration in the vertical direction. Now, a tricky point is positive acceleration does not mean an object is speeding up. It only means the vector for the acceleration is pointing in the positive direction. So if I have AX is greater than 0, that means the acceleration is pointing to the right. If I have AX less than 0, that means the acceleration is pointing to the left. AY greater than 0 means the acceleration is pointing straight up. AY less than 0 means the acceleration is pointing straight down. Well, how do we know whether that's going to result in an object speeding up or slowing down? We're going to get to this in a second, but the quick preview is anytime velocity and acceleration point in the same direction, which means they have the same sign, the object's going to be speeding up. Anytime velocity and acceleration point in opposite directions, that means the object is slowing down. Let's look at position, velocity, and acceleration in the x direction. Remember, position is where you are relative to the origin. X equals 0 means you're right at the origin. X is greater than 0 would mean you're to the right of the origin. X is less than 0 means you're to the left of the origin. Velocity indicates speed and a direction. Velocity equals 0 means you're not moving at all. So in this case, if I hit play and the velocity is 0 and the acceleration is 0, the man will just stay there. If I have a positive velocity, that means the object is moving to the right, and the greater the magnitude of the velocity, the greater the speed. A negative velocity means that the object is moving to the left. And again, a bigger negative velocity would mean you're moving to the left with a greater speed. Now, acceleration's a bit trickier. Acceleration is the rate at which your velocity is changing, but a positive acceleration doesn't necessarily mean you're speeding up. Let's take a look at a couple of examples. So in this example, I'm going to let the position initially be plus 10 meters. So I'm 10 meters to the right of the origin. The velocity I'll let be about negative 1 meter per second. So I'm starting off moving to the left at a speed of 1 meter per second, but my acceleration in this case I'm going to have as about negative 2.1 meters per second squared. So I have a negative initial velocity, I have a negative acceleration. Velocity and acceleration are pointing in the same direction. When I hit play, you can see this man is moving to the left, but the speed is increasing because he is also accelerating in the same direction that he's moving. Let's reset this again. So again, I'll give it a position of 10 meters, a velocity of, let's say in this case, it's about negative 2.5 meters per second, and a positive acceleration. Now again, a positive acceleration doesn't necessarily mean speeding up. Let's see what happens. Initially, this man is going to be moving to the left at about 2.5 meters per second, but since the acceleration is positive, we'll see what he does is slow down, slow down, slow down, slow down, stop, and then change direction. So here I had a negative velocity to begin with, a positive acceleration. We have initial position of 0, a positive velocity, and a positive acceleration means the object is going to be moving to the right and speeding up. A positive velocity and a negative acceleration is going to mean the object is moving to the right, decreasing in speed. Let me do that one more time. Let's give this a negative position, a positive velocity, and a negative acceleration. Here, again, they have opposite signs. So initially, the velocity was positive, the acceleration was negative, so the object was slowing down. And then if the acceleration stays constant, eventually it'll slow down, stop, and then reverse directions. So quick little summary. Position, positive means to the right horizontally, negative means to the left. Velocity, positive velocity means you are moving to the right, negative velocity means you are moving to the left, and the sign of the acceleration, you can't initially tell what's going to happen unless you also know the sign of the velocity. Velocity and acceleration point in the same direction, the object speeding up. Velocity and acceleration pointing in opposite directions, the object is slowing down. Let me give you a couple scenarios and see if you can reason through what's going to happen. So let's say I have an initial position that is positive. So we'll make it positive about 5 meters. I have a velocity which is negative 3.1 meters per second squared, and I have a negative acceleration. What is this man going to do once I hit start? Well, let's see the answer. First, let's reason it through. My initial position is positive, which means I start off to the right of the origin. My initial velocity is negative, which means I'm initially moving to the left with a speed of about 3.1 meters per second. Now, my acceleration is also negative, which means I'm going to be speeding up. And if the velocity and acceleration are negative the entire time, my speed will just keep on increasing. So once I hit start, man is moving to the left faster and faster and faster. Well, what happens if I start off with a initial position of negative 10 meters, a initial velocity, let's say, of 3.9 meters per second about, and an acceleration of negative, let's say, about negative 0.9 meters per second squared. What is this motion going to look like? Well, again, thinking about this, if my initial position is negative, I'm starting to the left of the origin. If my initial velocity is positive, that means I'm moving to the right. But in this case, my acceleration is negative, which means I am slowing down. So as long as the acceleration stays negative, eventually this object is going to slow down, slow down, slow down, stop, and then reverse directions. Now let's see. Physics works.
That was easy.
Well, that is it for today. Thank you so much for joining me. My name is Dr. Joe McCullough, and in my next video, I'm going to be talking about the equations of constant acceleration. What are they, and how do I go about solving constant acceleration problems in one dimension? Hope to see you there.